Scenarios 5 and 6 investigate the effect of product mix on the development method. These scenarios are a little more complicated than the earlier scenarios because now we're dealing with two separate lines of business instead of just one. So we have one set of paid and reported loss triangles for line of business 1 and another set of paid and reported triangles for line of business 2. We're going to combine them by adding the paid loss to the paid loss and the reported loss to the reported loss, and see how the development method performs when applied to these combined triangles. But let's step back for a moment and first look at the simulation parameters for each line. For line 1, the loss ratio is 60% for all accident years. For line 2, it's 80%. Now the case reserve strength will remain consistent for the whole simulation, so that's one less thing we have to worry about. The earned premium grows by 5% per year, starting at $600, and that's the same for both lines 1 and 2. The final result in scenario 5 is that if we add these lines of business together and estimate the ultimate loss with either the paid or reported development method, we'll get exactly the right answer. And that's what we're going to demonstrate. We're going to do our calculations using the combined reported loss triangles. The paid triangles work exactly the same way. These are the reported loss dollars for each line. Let's calculate the LDFs. We have stable development for both. The numbers up and down each column are the same. So at this point, you don't have to do any more calculations. You already know that when the LDF triangle is perfectly stable, then the development method will be perfectly accurate. If you check it, you'll indeed find that for line 1, the estimated loss ratio is 60% for all accident years. Same for line 2. The LDFs are different versus line 1, but the development pattern is also stable, so if you do the calculation, everything works. Let's flip back to the loss dollars. We're going to combine these triangles, in other words, add them together, and then apply the development method to the sum. Here's the sum. Question: what do you think the LDF triangle is going to look like? In particular, is it going to be stable? Because if it is, the development method is going to work great. How about that? It is perfectly stable. All the columns are the same. That means your development method estimates are going to be perfectly accurate, and the ultimate loss ratio for each accident year turns out to be 70%. You can download the Excel file and double-check those results later, but the key reason that adding these lines of business together worked out so nicely was that they both had a premium growth rate of 5%. There was no change in the mix of business. In scenario 6, we're instead going to let line of business 2 grow at 30%, but keep line of business 1 growing at 5%. Do you think we can combine them and still get accurate results? Let's find out. In scenario 6, the loss ratios are as in scenario 5. 60% for line 1, 80% for line 2. The case reserve strength is also consistent as in scenario 5. The difference is the relative premium growth rate for line of business 1 versus line of business 2. For line 1, the growth is going to stay at 5%. But for line 2, the growth is bumped up to 30%, quite a significant increase, and that's going to make a big difference. Note how in scenario 6, the earned premium split between lines 1 and 2 starts at 50-50, but because line 2 grows faster than line 1, it takes on a progressively greater share of the total premium, and the split is roughly 25-75 by accident year 6. Let's look at the data triangles. This is the reported loss data. There's no difference for line 1 if you compare to scenario 5 because we've maintained the 5% growth rate. But the 30% earned premium growth rate for line 2 is also reflected in the growth of the reported losses. For the first development year, we see a reported loss of 96 for accident year 1. This increases by 30% per year as you move down the column. Now compare this to line 1, which actually starts out higher than line 2 at 144, but here the growth rate is only 5%. So when you get to accident year 6, the reported loss for line 1 is actually less than for line 2. Let's calculate the LDF. We have stable development for both, just like in scenario 5. The numbers within each column are the same, which means the development method is going to work perfectly. Recall in scenario 5 when we combined the data, the development method still worked perfectly on the combined triangle because the LDFs were still stable. But it isn't going to work out like that here. Let's flip back to the data and see why. Let's merge these two triangles together so we can take a look at the sum. Now you can't really tell much just from looking at the loss data, so let's flip to the corresponding LDFs. You can clearly see, because I've marked it in red, the LDFs within the columns are not stable. In fact, there's a definite increasing trend. So before you even do any of the calculations, you know you're not going to get accurate results using the development method. I chose the all-period average for my LDF selections, and that's not actually the best choice. Since there's clearly an upward trend as you look down the columns, the all-period average is going to be too low, which means my final estimates are going to be too low as well. Now, if you're registered for Battle Axe, you can download the Excel file and play around with the selections yourself. See if you can do a little better. And here are the results. Our estimates for accident years 1, 2, and 3 are accurate and are highlighted in green. Remember, this data is based on a simulation, so we know in advance the true accident year ultimate loss ratios. Our estimates for accident years 4, 5, and 6 are too low and are highlighted in red. The key takeaway here is that the development method underestimates the true accident year loss ratio. That's because the growth rates differed by line, so we did have a change in the mix of business. The resulting combined triangle did not have a stable development pattern, and that's what caused the problem.